What's going on, guys? So in this video we're going to talk about another sorting method. So this is the selection sort, and it's not the most efficient sorting method because it runs in O of n squared time, but it is a nice little sorting method nevertheless. So basically what's happening is that we look at the very first index and we store that value as our minimum value. And then we're going to check the rest of the elements, and then we're going to compare it to this element right here and see if it's less than this element right here. And if it is, we're just going to swap the two values. So the 5 right here, we're going to set that equal to our minimum value. And then we're going to look at this 8 and see if 8 is less than 5, which is not true. So we go to the next value and we see that 2 is indeed less than 5. But 1 is less than 2. So basically what happened was that 2, since it's less than 5, it's now equivalent to our smallest value. And then we move to this 1 right here, and now that becomes the smallest value because it is the smallest value in the array. And then all we do is swap this 1 with this 5. And we keep on doing that until the entire array becomes sorted. Let's go ahead and see how we can implement this in Java. So basically, I'm going to write the code for the selection sort inside this public static int sort, and we're going to show the array. So basically here, all we have to do is just print out the values in the array. So we're going to have our outer loop, and we're just going to write int I is equal to 0, I is less than array.length, and I already defined array in our main, so that's why I have ARR. And then we're going to set the minimum value equal to the ith index. And now we're going to write the inner loop. So the inner loop will have the same values, but it's going to be one placement to the right. So we're going to have j is equal to I plus 1. J has to be less than array.length, or else we're going to go outside of the bounds, and then we just increment the value. So we're going to have a conditional statement that says if the array at index j, so the next value, if it's less than the array at the minimum index, so at I technically, then we're just going to set the value is equal to the min. So min is equal to j. So what exactly happened here? So remember, we have this 5 right here, and it's going to check if this 8, which is I plus 1, so if j is less than 8, we're going to swap the values. But since 8 isn't less than 5, we're not going to do anything, and we're just going to keep on moving through until we see which one's the smallest. And that case will be 1, and then we will swap this 1 with a 5. So now this is the tricky part of this sorting algorithm. This is where we have to swap the values. And it may seem like you just set one equal to another, but in this case we need a temporary variable, or else we lose one of the numbers. So we're just going to define temp is equal to the array at min. And then since we're going to override the value, min is now going to be equal to the value at the ith index. And then the array at the ith index is now equal to, well, 10. So since this is a public static, we need to return something. So we need to return an array. So let's go ahead and print this out and see what happens. So as you can see, we have 2, 5, 6, 8, and 10. And that's exactly the numbers that were in here, and now it's just sorted. So what exactly happened? So the numbers that I had in my drawing aren't the same as this. So let's quickly go over what's happening with these numbers. So here I have 8, which is set to min. And we go through the inner loop. So our inner loop starts off at j is equal to I plus 1. So j is now I plus 1, which is 5. And it sees that if array at j is less than array at min, so if 5 is less than 8, what do we do? Minimum is equal to j, or min is equal to j. So min is now equal to 5, since this is the smallest value it's seen so far. So it doesn't see this 2 yet. So we go to 6, and that's no longer less than 5, and we see that 2 is in fact less than 5, which is min. So now 2 becomes min, and once that's done, we swap the values. So the temporary variable is now array at min, and then array at min is equal to array at I, and then array at I we set back to our temporary variable, and that swaps the values. So we keep on doing that and find the smallest number and then put it in the front. Smallest number and then put it in the front. And then we'll have our largest numbers in the back. So that's pretty much all there is to this selection sort. Again, it's not the most efficient because it runs in O of n squared time, and the reason why is because we visit every single value twice, because we have these two for loops. We have a nested for loop, so that's why it's n squared. So it's really inefficient, and this is usually good for small amounts of numbers. So I really hope this video helped. This was a quick explanation on selection sort, and in my previous video I explained the insertion sort, and then we'll move on to merge sort and the binary search and a whole bunch of other things in the future. So I really hope you stay tuned for that, and as always, please remember to like, share, and subscribe, and I'll see you in the next video. Thank you so much for watching.